All right. So as we go through this, first thing first, is this first function, is this first picture, the black Z shape, is that a function? Be prepared to answer when you're called upon here. Noah, is this black one a function? Noah, you there?
Yeah, I'm here.
What do you think? Function, not a function?
I'm not sure. I can't even see anything. My screen is all dark. I don't know why.
The screen is blurry. It's hard to see it.
Okay.
I can't see anything.
All right.
3 and 4. I was waiting for a 4 to 3 and 4. That's awesome.
I'm not sure why. It worked. First hour worked really good. I have no clue why. First hour we had no issues. I asked how's it going, and everybody was good. All right. So unfortunately I didn't record this first hour. I'm recording this hour, so I'm not sure what's going to happen here. I have a Z shape here. As I move my hockey stick across here, I apologize for the video. As I'm going across the Z, I'm hitting nothing, nothing, nothing. It's here I start hitting 1 point, 1 point. But right when I get between the -1 and the 0, I start hitting multiple points. So there's more than 1 point in a vertical line, so it's not a function at that point. So the answer to this first one is no. Okay. Tomorrow I'll try recording from school. Hopefully that works better. Domain and range. Domain, what is the graph doing from left to right? So when I do domain and range, I'm only looking left to right for domain and bottom to top for range. So as this graph goes, it starts at -2 and goes to +2, left to right. I'm not going to use the squiggle. I should not be using that. I'm going -2 to 2. -2, I have a closed circle, so I'm going to use a bracket. At +2, I have an open circle, so I'm going to use parentheses. As an inequality, I know my x values must be greater than -2 or equal to, and they must be less than +2. Now the range, we have to look at the graph in a completely different way. We look at it from just bottom to top. There's nothing down here and nothing above it. There's just this area in between. So for a range, okay, I'm going from 1, and I know there's an open circle at this y value, but it is closed along here all the way. So I'm going to use a bracket. It goes as high as 3. Then it stops again. Once again, because I have a closed circle at 1 and 3, I'm going to use the brackets. For the inequality version, I'm going to say y must be greater than or equal to 1, and y must be less than or equal to 3. So the y values have to be greater than 1, but less than 3. All right. For this function here, for the green one down here, all right, I'm going to try this again. As I take my hockey stick across the graph, nothing, nothing, nothing. At that open circle, I still have nothing, but then I start at 1 point, 1 point, 1, 1, 1, 1, 1, 1, 1, 1, 0, 0, 0. At no point do I have any two things right above each other. So there's only 1 point. So yes, this one is a function. Okay. Domain, range. Pretty good there. All right, now domain. I'm starting at -1 and I'm going over to 2. -1 to 2. Open circle at -1, closed circle at 2. Range, I get as low as 0. There's nothing down here. And I go up, and when I get to 3, it stops, and there's nothing above it. So at 0 to 3, it's a closed circle at 0. Open circle as high as 3. We'll use parentheses. All right. Now we'll do our inequality versions. X must be greater than or greater than -1, and X must be less than 2. Y values. Y must be greater than or equal to. Oh, I forgot the equal to on the 2. And Y must be less than 3. Now, what you're going to see on the test is going to vary. They may say, hey, just what is the domain or range? Or they may be specific. They may say, hey, you have to use inequality notation. Or you must use interval notation. So you have to be prepared to do both. So keep that in mind come test day.
Wait, when is our test?
We test every Friday.
Okay.
Every Friday during class. So you need to be here on Friday's class, take the test. There is going to be a video. What you're going to see is what's being recorded right now. I'm going to try going into school tomorrow, see if that makes a difference off my whiteboard there. I'm not sure why second hour's having the issue. First hour had no issues. All right.
I have a question. I sent you email because I had an issue getting in the class, so that's why I came in late because I had issues joining the class.
Okay. Who is this? I'm sorry. Who is this? I'm sorry. Damani. Okay. I won't mark you absent today, just so you know. Or I didn't mark you absent. I have you on the attendance sheet.
Oh, okay.
All right. So today's lesson is going to go a little bit quicker than yesterday's. We have 2 types of problems to cover. That'll help you through today's worksheet. I'm going to keep these 2 pictures up. We're going to use them again as we go through this. All right. We are on chapter 4, section 1, day 2 today. Function notation. Y equals, that's right, 2x minus 3. We've graphed this numerous times this year. This would be a line. We would start down 3. We go up 2, right 1, up 2, right 1, up 2, right 1, and we draw a line. This is known as an equation. I'm going to write the same exact equation as a function by making one change. Instead of writing y here, I'm going to write f of x. Sorry. It's pronounced f of x. That's how you say this. This is a function. Okay, now the difference here is basically nothing. If I go to graph this function, I would still start down 3 and go up 2, right 1, up 2, right 1, up 2, right 1. It's just a different way of writing it. All right? These two things basically mean the same thing. Now, the advantage to this new method, you've done this before in pre-algebra and algebra 1, is when you go to plug a number in, that stays here and you can see what your x value was when you started. So when you finish, you'll have an x value and a y value. You'll have a point that you're ready to graph. Now, as I do this, please get this out of your head. I have a bunch of kids like, oh, I divide both sides by f, or I divide both sides by x. This is not multiplication here. This is a function. It's just saying, hey, this is function f. There's going to be a function g and a function h. The letter out front is just the name of the function. It is not being multiplied by x. So what you're going to be doing today is they're going to give you values to plug in for x. So for example, I may say f of 5 of the function 2x minus 3. And what you're going to do then, as you work through this problem, is wherever you see an x, you're going to replace it with this number. So I'm going to go 2 minus 3. I'm going to plug in the 5. 2 times 5 is 10. 10 minus 3 is 7. So when I'm done, instead of having y equals just y equals 7 when I'm done, when I get down to the bottom, it says f of 5 equals 7. So basically it's saying you have a point when x is 5, y is 7. You basically have the point 5, 7. It's a way to remember what you plugged in and what you got out. This is your input. This is your output. For every input, you're only allowed to have one output. That's what we talked about yesterday. Why is something a function and why is something not a function? All right. Everybody good there? All right. I'm going to show you. I'm going to give you one example of what you're going to see today. I'm going to give you a function that's a little bit more difficult. My function is f of x equals 4x squared minus 9. Then I'm going to give you 3 problems. Problem A. I want you to find f of 5. Problem B. Find f of negative 3. C. Find f of 2.5. So what you're doing now is you're going to work with the same function 3 times. The first one here, you're going to plug in 5 for x, work it out, PEMDAS. Second one, plug in negative 3, work it out, PEMDAS. And this last one, you're going to get decimals. Sometimes you're going to get fractions, sometimes you'll get decimals, and you'll plug them in. All right, so I'll give you about 3 to 4 minutes to work on these 3 problems. Can I ask you guys a question? Is one side of the screen less blurry than the other? Okay. Oh, this is good stuff. Love technology. All right. Well, I'll try tomorrow's lessons from my classroom, see if that works any better. All right. So as I go through these, I'm going to have 4 squared minus 9 in all problems. And I simply plug in my missing value. I'm going to plug in 5 for this one. Because this one has a negative, I'm going to put it in parentheses. And then times 2.5. Also in parentheses because of the decimal. So as I work through these, this first one's going to go a lot easier. PEMDAS exponents first. I'll get 4 times 25 minus 9. Now this negative 3, when I square it, remember negative times negative is a positive. I'll get a positive 9 minus 9. This one we get a decimal. I'm going to get 4 times 6.25 minus 9. PEMDAS says we're going to multiply next. I will get 100 minus 9, 36 minus 9. And then if you take 4 times 6.25, you'll get a 25 minus 9. To give you a heads up in your homework, there's a 3/2 in the homework. Well, 3 divided by 2 is a decimal. It's 1.5 that you can use as a decimal if you prefer. All right, 100 minus 9 is 91. So like I said before, here's my x value is 5. My y value is 91. If we're graphing, we could put a point at 591. Same thing down here. F of negative 3 equals 27. And f of 2.5 equals 16. So this is going to be half of your homework is doing this sort of stuff, just simple algebra, plug in, do your PEMDAS. The other half is you're going to get graphs like these. And you're going to see things like this. They're going to go, what is f of negative 2? What is f of 0? And what is f of 1? I'll stand off to the side here maybe and get a little sharper image, hopefully. Okay. So they're going to give you problems that look just like the last one, except there's no equation. There's nothing to plug in. Okay. What you're doing then is they're giving you x values, and they want to know what the y value is at those x's. So you look at the graph, you say, okay, when x is negative 2, what is the y value? So as I go in here, here's my x is negative 2. My point's right here. The x is negative 2 right here. What is the y value at this point? What is the y value at that point? If you want to type in the chat, feel free. Thank you. All right. When x is -2, my y value up here is at 3. Okay. See if you can do these last two when x is 0 and when x is 1. Now, 0 is a trick. There's a trick to that one. They're trying to trick you on this one. There's more than one answer, to give you a hint. All right. So, once again, I apologize if you can't see this very well. When x is 1, right here, what is the y value? So when I go up here on x is 1, y value is also 1. When x is 0, the trick is there's 2 points. There's one right here, and there's one right there. So there's 2 values. So you have to do it twice. So I go f of 0. At 0, it's 1 and 3. Now, that right there is the reason why this is not a function, because the input 0 has 2 different outputs. All right. Last one here. See if you guys can do this one on your own for this graph. Let's go f of 0, f of 1, and f of 2. Now, at 0, you're going to get a decimal. Don't be afraid. Just make your best estimate. It's not exact. All right. So as we go through this, f of 1, right here is this point down here. We have a point at 1, 0. Y value is 0. When x is 2, our y value is 1. First hour, we had a guess of 0.5. I'd take 0.5, 0.6, maybe 0.7. I would not give you a problem like that on the test if it wasn't a nice exact number. All right. Last thing I want to mention. If I give you the similar problem that we just did earlier, x squared minus 7x plus 5. This has 2x's. Say my value is 5 to plug in. I plug the 5 into both spots. 5 goes into both spots, so keep that in mind as well. All right. Next thing. Anybody have any questions off yesterday's homework assignment? Anything they're not sure about from yesterday? All right. In that case, you guys are free to go. I'll be on for a couple minutes if you have any questions. That'll be it. I'll put select answers. Yep, Brooke, I'll put those up as well.